Okay, good afternoon, everyone. And on behalf of INCOSE UK and the Energy Systems Interest Group, I'm delighted to welcome you all to our panel session on a systems approach to the energy transition for net zero. For today's session, we've been very fortunate to gather a diverse panel of systems thinkers and leaders in their respective fields, and we hope to deliver an informative session with a great opportunity to address questions from a wide audience. Our thanks go to the Energy Systems Catapult, Energy Technology Partnership, Scottish Enterprise and the local Energy Systems Scottish Industry Network for helping make this event happen. And thanks also go to Strathclyde University for providing a physical venue, which unfortunately we were unable to follow through with, but we're delighted to be here today in a virtual capacity. For those that don't know, INCOSE UK are a professional engineering institution with the aim of furthering the cause of systems engineering in the UK. And as Sir Patrick Vallance said just last week, almost everything that we do across government requires an engineering mindset because it's a systems problem and engineers think about systems. At INCOSE, we believe in a better world through a systems approach. And the Energy Systems Interest Group have a vision that a systems approach will play a key role in an effective energy transition that delivers not only net zero, but positive outcomes for society and the natural environment, and with minimal unintended consequences. If you share that vision, then please do reach out to us and get involved. My contact details are at the bottom of the screen now, or you can join us at INCOSE's annual engineering conference in 2 weeks' time by following the URL, which is also provided below. A couple of small housekeeping notes before we start. Firstly, just to make everyone aware that today's session is being recorded. And secondly, please use the Q&A button to submit any questions that you have for the panel. And you can do that at any time throughout the session. You should also be able to vote on the questions that have been entered, and then the preferred questions will rise to the top. So we'll hear the perspectives of the panelists across the first hour. And then for the final half hour, we'll take to the Q&A to answer questions from the audience. But before we proceed to the panel session, it's a privilege to welcome Professor Sir Jim MacDonald, who I'm sure most of you know. He holds several positions, including the Principal of the University of Strathclyde, Chair of the Energy Technology Partnership, and President of the Royal Academy of Engineering. Over to you, Sir Jim.
Thanks very much, Peter, and good afternoon, colleagues. It's a real pleasure to be joining you in this session. Of course, deliberately timed to coincide with one of the most important meetings this century and further into the century around COP26. And without unpacking all of that, one or two of us, of course, have been spending a lot of time in the blue zone recently. And the term systems and understanding the complexity of what must be addressed in order to deal with climate change, I think, is becoming now the regular way of engaging policymakers, technologists and investors. And being no doubt, and I hear this from COP veterans, that the fact that there have been so many representatives and senior decision makers from the finance industry and indeed from industry and business, I think indicates that there's a requirement to move, because we've all heard time and time again what this is all about and why it's important. What we haven't heard enough about is how we're going to deal with it and when it's going to be done. So that's where systems approaches become critically important. For Patrick to have indicated that systems engineering point of view, I think was important too. I've got the privilege of sitting on the Prime Minister's Council for Science and Technology that Patrick co-chairs, and he's a great advocate for this approach, and he's also trying to engage multiple departmental engagement across UK government around that systems approach. Because of this large wicked problem of climate change, we need that multi-dimensional, multi-skills, multidisciplinary approaches that systems approaches can facilitate. Just as you go into the discussions today, I would point out to you some key landmarks from my perspective. The Council for Science and Technology published, I think, an important letter that was taken on just about in its entirety in January 2022, which was entitled Achieving Net Zero Through a Whole Systems Approach. Some of that work has, of course, been supported and formed by the Energy Systems Catapult team. I know members of INCOSE have made contributions in that journey, but the Royal Academy has put a lot of framework around that and some thinking that brings the rigour and the discipline that is so necessary to tackle this big, challenging problem, but do it in a way that we can deconstruct it, see where early engagement can be made, do the modelling, and then, and I'll say this from an engineering point of view, then move to deployment. Let's move to these low regrets options, which I'll refer to again very briefly, Peter. So that systems approach, of course, it's about technology and innovation and infrastructure, but of course, it's about how that interacts with policy, how it interacts with the financial systems that are so necessary to underpin this, but also how it engages with society. And the Royal Academy of Engineering has published a number of papers through the National Engineering Policy Centre, which is hosted at the Academy, involving, of course, the Academy itself and over 40 professional engineering institutions. We're bringing together a group of, that represents across the patch 450,000 engineers, let me tell you, but NEPC is now being drawn upon regularly by Sir Patrick, by the Cabinet Office, by other actors to see how we can bring that structured approach, that systems thinking, the systems engineering that allows us to address climate change in a more structured way. And we've already published on how we might decarbonise homes in that structured approach, recognise the interaction with transport, local government, public behaviour, how it works on energy sources, design new materials. We've also given advice to the House of Lords on that, the hydrogen infrastructure that will be required, and made comments on carbon capture and storage. And the last thing I would say is, and I do commend you have a look at it, because as we move towards away from what and why, which is well understood, to the how and when, we need to get moving. 2050 is less than 1,500 weeks away, and 2030 is going to be a massively important marker on that journey to net zero and decarbonisation. So we need to get to what we call low regrets options. And just last week, the Royal Academy of Engineering published a paper called Rapid Low Regrets Decision Making for Net Zero Policy. And with support from Patrick and many others, we're now looking to align the public and private sector investors to get in place what we need in terms of making that journey to net zero. And I'll conclude by saying the obvious ones, it's not exclusive, but the obvious ones will be reducing energy demand, such as providing incentives to change consumer behaviour, improving efficiencies in resource and energy use across domestic transport and the built environment, including retrofit. Again, you can imagine a systems map that sits behind that in terms of interdependency, and scaling up deployment of proven technologies such as battery electric vehicle charging network. And you heard some announcements from the UK government earlier this week, and demonstrating at scale and with involvement of industry, unproven and yet critical technologies, including hydrogen and carbon capture and storage. And we've been seeing some recent announcement from government on that. So I'll conclude, Peter, by saying the timing is right for this. This is the time for systems thinkers. This is the time for systems engineering rigor and structured approaches to be applied. And we don't have a lot of time to prevaricate. So let's use events such as this to start feeding the thinking into our friends and colleagues in the policy making community. But let's use it as a magnet to bring technologists, innovators and investors together to start proposing solutions. And let's move to the solution space rather than be tied down to the problem space. And again, that's where systems thinking can help. So I'm sure this is going to be an interesting event. And Peter, I'll pass back to you now. Thank you.
Thank you very much, Sir Jim. Excellent introduction and context setting there for today's discussion and why it's so important. So we're going to move on now to our panel session, where we'll hear from each of our 4 panelists in turn, and they'll give a bit of a presentation around what it means to take a systems approach and what some of the key benefits and challenges are. So first up, we're going to hear from Guy Newey. Guy is the Strategy and Performance Director at Energy Systems Catapult. Prior to that, Guy worked at the UK Government Department of Business, Energy and Industrial Strategy as a special advisor to Greg Clark and Amber Rudd on energy policy. And prior to that, Guy was Head of Environment and Energy at Policy Exchange, which is one of the UK's leading think tanks. So Guy, over to you, thanks.
Good. Assuming I've got the engineering right, that you can see the slides, I'll get going. So I'm not an engineer. I'm not a systems engineer. I'm not an electrical engineer, a chemical engineer. I'm not even a civil engineer. So what the hell am I doing on a Friday afternoon talking to you about how to take a systems engineering approach? Well, as Peter said, I am a humble, or perhaps not very humble, policy person who was lucky enough to work at a pretty senior level in the government thinking about net zero and the decarbonisation challenge. And I guess this talk really could be about what I wish I'd known when I was in those roles that could have really helped thinking through this challenge, and particular, as Sir Jim said, this challenge, the kind of how are we going to do this? We spent a lot of time debating about what we need to do, but the how, the practical, is really essential. So this is in many ways a talk to myself of 4 or 5 years ago when I first went into government about how a systems engineering approach could help. So just think about the problem that this is where we are today, and this is where we need to get to over the next 30 years. So first of all, this is net zero nirvana. So we achieve net zero. This is the UK context, but you could equally think about it globally. It's cost effective, so it doesn't cost us too much. It creates innovations and jobs across the country for the kind of organizations we work with at the Catapult, who are the kind of businesses trying to really crack this problem. And it provides an example to the rest of the world. Great, that's how we want to get to. But of course, there are lots of other net zero worlds that we could end up in. A very expensive one, a political disaster one, where we get kind of Gilets jaunes style protests on the streets. And of course, there's many versions of the future that we don't meet net zero. Other things are deemed more important. It's too difficult politically. So how can systems engineering help? Well, really, the way I like to think about it, and the way we articulate it to policymakers when we're talking about it, is it's not prescribing exactly how the path is, but it's giving you that kind of the tram lines to make yourself to work towards that. So thinking about where you're doing your innovation, where you're learning, where your deployment should be going fast, and understanding the kind of order of things to do that. Because we can all produce scenarios about how we're going to get to 2050. This is from some of the modelling work that the Catapult did. This is one of our scenarios going forward. But the ranges and uncertainties are huge. Look at the difference in the size of those electricity systems you could have. You could see perfectly feasible 600 terawatt hours, twice as big as the one today. It could be 800 or even bigger. There are a lot of uncertainty about what we are facing. So therefore, we can't just plan it, but we still need an approach, and the systems approach can really help us get there to that world. So I'm sure Hilary and others are going to come up with kind of perhaps cleaner definitions of systems approaches and system engineering, but really at the heart of it is about solving the right problem in the right way, and of course thinking very hard about what that problem is. It's absolutely suited to the complexity of a challenge like net zero. It is whole system, and I'll talk about what that word is wonderful. We're very delighted at the Energy Systems Catapult. The whole system has become a cliche in the energy sector space, but probably needs a bit unpacking. It's about trade-offs and interactions and synergies. Trade-offs is, as a former political advisor, something that politicians not wild about. They prefer the kind of cakeism of everything working out well, but the reality of this is there are choices, and crucially it's an important way of engaging stakeholders. So just a quick slide which we find useful on what a whole system approach is, and I think Sir Jim articulated this pretty well as well, is think about that whole value chain, right from the sources of generation through the pipes and wires, through the buildings, and those annoying things at the other end, which I used to call voters, I now call consumers, and other people call people. It's about thinking about cross-vector, and we're already seeing that breaking down in lots of ways, but it's also thinking about how all these systems work together. I'm a policy person, so I thought if you get the markets right, everything else will follow. Now I spend a lot of time hanging out with engineers. I realize the physics is a bit more important, and we're about to have this digital system land on top of us in the energy sector, which is both exciting and a huge challenge, and we need to think through what that's going to mean. We did a piece of work for government, for Dominic Cummings, remember him, and others, which tried to kind of set out an approach for what policy makers should be doing if they're thinking about a systems engineering approach. And this is the kind of, be familiar to lots of you. This is the kind of way we think about these things. And just going to bring out a couple of points there. So first of all, it provides a really useful context for engaging stakeholders, from across disciplines. Government actually generally is really bad at this. It's very nervous about giving any indication of what it wants to do. It has a few quiet meetings with a few chosen people, and whereas an open process would be much more powerful and important, and actually would help government deliver stuff faster. And by the way, in areas with things that we've been involved in, we've been very proud that, such as the Energy Data Task Force, faster progress has come because you've been open at the start. It's about testing different options, and crucially, and policymakers are terrible about this, it's about checking that things are working, verification and validating that they're actually being successful, and then looping back and learning. That point about continuous improvement. We tend to dump a strategy, policymakers tend to dump a strategy out there, fingers crossed it will work. And if not, it'll be someone else's problem to sort out if it hasn't. See many of the policy failures over the last few years. One of the areas which is particularly important in terms of systems approaches is at a local area. I'm not going to go into detail here, but we at the Catapult have done lots of work mapping out, thinking about priority innovation and deployment projects at a local level. And then helping local authorities implement those. That's absolutely essential. It's quite weak. It's kind of nodded towards in the net zero strategy recently, but nowhere near the level we need. And that is crucial to that point about how is this going to work on the ground? How is it actually going to operate? We're a bit complacent about that, I think, in the policy terms. So what tools would you need if we're serious about systems approach from a policy making point of view? So, getting the system of systems map. There's a bit of danger when we talk about this. People think it's a kind of perfect answer. You're going to plug in all your inputs and it's going to pop out the answer, and policymakers are kind of seduced by that. No, it's about a structured way of thinking about these problems. We need, a regulatory and governance regime which is much more agile than we have now, and I'm sure others will touch on that. We need market simulation tools which are really going to explore different futures rather than just making a policy decision. Can we do that? Think about market design. We need real world environments to test, living labs and pathfinders. Let's really go fast on places, and so Jim's paper on for the Council of Science and Technology is really strong in some of these areas, and we at the Catapult have kind of built a living lab and are working with Strathclyde with a power network demonstration centre to really move forward on that. And crucially, you want to get some roadmaps, some real plans that people can invest off the back of. So that's the value. That's the magic that engineering and systems approaches can provide, and that's what we need to move towards as quickly as possible, recognizing the huge pressure we are under. Thank you.
Thank you very much, Guy. Next up, we've got Maxine Freirk. Maxine was previously at Ofgem in a variety of roles, most recently as Senior Partner of Networks. She's now an independent consultant, chairs the Consumer Engagement Group for a gas network, and sits on an equivalent group for an electricity network. She is an associate with the charity and think tank Sustainability First and a visiting fellow on the Integrating Renewables programme at Oxford University. Maxine holds a degree in management science from Cambridge University. So over to you. Thanks, Maxine.
Thank you. And a bit like Guy, I start by saying, so I'm not a systems engineer. But as you heard a long while ago, my degree was in a slightly related subject, so I've always had a lot of support for the kind of systems way of thinking about things and the role that engineers played in Ofgem and beyond. So really what I want to do is pick up on a few of the themes actually that Guy's already touched on. The first one around the importance of whole systems thinking. Guy actually put up his definition of whole systems, which I think is fine, but what I wanted to reflect on was actually how that has shifted over time. He's right, you know, whole systems is now an absolute buzzword. Ofgem require all of the companies to have, you know, set out what they're doing on whole systems in their business plans that they're about to submit as part of the regulatory process. But that does cause quite a lot of debate about what whole systems is. And I think it's fair to say, if you wind back 5 or 6 years when the idea was first introduced, and the systems engineering folks were pushing the idea of a systems architect, it was actually just looking at the electricity system. At that stage, it was quite a revolutionary idea that you should think about both the distribution networks and the transmission networks together as a system. I think a little while after that, we managed to kind of say, well, actually, you need to be thinking about the electricity system and the gas system together, and the definition of whole systems got broadened out to think about the two bits of the, if you like, the energy world that Ofgem regulated. But now it's becoming increasingly clear, isn't it? You know, we've got to think about electric vehicles, what are we doing on heat decarbonisation, and all of those have very real and immediate impacts for the energy networks. And so Guy's picture that he drew covered those, you know, electricity, heat, gas, and transport. But I'm increasingly seeing as well a sense that actually whole systems can go beyond that. You know, there are links with water. There's important interdependencies with communications networks. And so really for me, whole systems is about just keeping a very open mind about all of the interactions that whatever system it is that you're looking at might have, going beyond the kind of immediate focus that you've got. And the other twist I've had is that it isn't just about thinking, and what can you do for my system, but thinking about what can my system do for you. So, you know, there's some sort of important interplays there, and recognised by the Committee on Climate Change when it's thinking about adaptation. It's really pushed the importance of resilience in the electricity system because of the knock-on impacts that a failure in the electricity system would have for all the other systems, for communications, for water, for everything that we do. So a broad approach to thinking about whole systems, but that's why, you know, the systems engineering approach is really valuable there. And then the other bit that the Guy touched on is, you know, thinking about people as part of that system. And Jim referenced it as well in his comments about heat decarbonisation, and ultimately that's about people and doing things in their homes, and the way that we behave in terms of the devices that we use and everything else. It becomes a part of the system. And I guess the first plea, and I don't think you fall into that trap, but is to not think of people as kind of rational beings that you can simply kind of model in a system. But if you think about the different drivers and everything else, then the systems approach can actually yield insights as well about how the consumer behaviours might impact on the wider system. In fact, a little exercise that Guy and I were involved in recently with Oxford, where we spent a day trying to draw a systems map and then kind of look for where there were feedback loops that created some interesting dynamics. And one of those was around the kind of consumer attitudes, and the more people that take up heat pumps and are happy with them, the more that will get positive feedback messages to other people, and you know, hopefully one is looking to see things taking off through that kind of feedback loop. So that's a sort of systems way of thinking about what other people might just think of as human behaviour, but you know, it is susceptible. Even thinking about people, it is valuable. Brings a systems approach is valuable. And then finally, back at the other end of the spectrum, you know, there's still a relevance in terms of the kind of pure technical side of things. And I was put in mind of the problems that we had down in England 2 years ago in August 2019, where one generator coming off the system for good reasons caused issues with voltage that caused other bits of kit to trip, and the perturbations ultimately then caused the trains to stop, What we found was the trains then couldn't move again because having suffered that kind of outage, they then needed a real person to come along and start them. So again, that shows both the kind of joined up nature of the systems that we are in, the importance of a kind of pure electrical engineering systems analysis of what happens when you take one bit of kit off a system, to the kind of the more technical measures of voltage and other things that I don't really understand myself. But the fact again that people in the system and whether you need somebody to come and fix your train, which is not a very efficient way of dealing with things, but really understanding properly by working through the impacts of any kind of bad scenarios to kind of work through from a systems point of view what all of that might mean. And I think in all of those things, the stakeholder engagement that again Guy touched on is important. Systems engineering can be a useful way of having that dialogue, but it's also an important way of gathering the insights to help you understand the interactions and those conversations with people. If you have a diverse audience in the room, they can help you understand the interactions of the energy system with other things you may not have thought of. So that, for me, is one of the real values in having wide stakeholder engagement. There are many values, but from a systems point of view, it helps you build that bigger picture. So I think with that message, whole systems, people, there's technical value as well, but kind of wide stakeholder engagement, 4 messages I leave with you and we can come back to in the discussion, I'm sure.
Thank you very much, Maxine. And next we'll move on and hear from Hilary Silito. Hilary is a physicist turned successful engineer and has accumulated 8 patents during his career. His appointments included Chief Engineer for Thales Optronics in Glasgow, Head of the UK MOD's Integration Authority, and Systems Engineer and Director for Thales UK. He's a Chartered Engineer, a Fellow of the Institute of Physics, and an internationally recognised expert in systems engineering and systems science. And including that, he is one of approximately only 50 living Fellows of the International Council on Systems Engineering. And he is also a member of the Omega Alpha Association. Hilary has also held visiting professorships at the universities of Bristol and Strathclyde, and his book Architecting Systems, Concepts, Principles and Practice was published in 2014, and more recently, just last year in fact, he co-authored another book published which is called Scotland 2070, Healthy, Wealthy, Wise, and is an ambitious vision for Scotland's net zero future without the politics. So take it away, Hilary. Thank you.
Right, thanks very much, Peter. I noticed there's a few other, including as well as me, ex-presidents of INCOSE UK on the call, and thinking back to how we were trying to get the message across 15 years ago, and having listened to the last 2 presentations, I think my work is done, all sorted. You guys know what you're doing. Not quite. There's some points Maxine made that I'm going to pick up on. So a reminder why we're all here. This is what the Arctic sea ice looked like 2 summers ago north of Spitsbergen at 80 degrees north. And it's getting more watery and less icy, as we all know. Fortunately, that's no longer seems to be a subject of debate. We worked in INCOSE on updating our definitions of systems engineering and systems, because the definitions we were using were rather 20th century, focusing on the very, very important and critical technical stuff, but not looking far enough out into the wider systems that Maxine was talking about. So we've generalised the definition, and I want to make the point that engineering and engineered in the widest sense are the action of working artfully to bring something about. And an engineered system can be any or all of people, products, services, information, processes, and natural elements. And I also want to emphasise the transdisciplinary aspect of systems engineering. You're not just grabbing the disciplines you need, sticking them together and telling them to get on with it. You're trying to get some sort of integration and fusion, and I hesitate to use the word optimization because it's picked up wrongly across the actions of all the different disciplines. And An engineered system is a system designed or adapted to interact with an anticipated operational environment to achieve one or more intended purposes while complying with applicable constraints. And here I need to notice there's been some comment on the chat about the word holon, and a holon is a kind of thing that can be considered as a system as itself, also existing within a wider system or wider systems. And the issue here is to resolve the problem, not just dump it on someone else. And I found this brilliant diagram on Facebook just a couple of days ago. Thank you to Jan Konietzko, whoever you are. An awful lot of the discussion about carbon and global warming is myopic on carbon emissions. Now, there's lots of different ways of reducing carbon emissions and increasing carbon drawdown, and they all have different impacts on all the other things in that circle, notably biodiversity loss, overconsumption, inequality, resource scarcity. You can read it. And an important thing about the systems approach to net zero is we're trying to reduce carbon emissions and increase carbon drawdown while making the world a better place in other respects. And solutions, I'll come back to bioenergy, carbon capture and storage, solutions that don't achieve that have adverse impacts on air pollution, biodiversity, land conversion, freshwater withdrawals, ocean acidification, chemical pollution, and on human well-being are not whole system solutions. They're a single point solution designed to focus on one metric to the exclusion of the others. Anybody who's not familiar with this diagram on the right, this is Kate Raworth's donut model, and I think it's the best attempt I've seen to show how the social foundations for society and the planetary boundaries of environmental damage between them define this safe and just space for humanity that we are trying to find a way of living within. And of course, so from the point of view of the UK energy system, we're the energy providers into the social foundations, and we are trying to avoid triggering climate change and all these other things. And in terms of physical context, we are this little island on the northwest corner of Europe, on the east side of the Atlantic, on the south end of the Arctic. There is something wrong with my slides here. Oh no, yeah. So move on. So the key thing about systems engineering and a systems approach is first look out from the system to understand the other systems that you're interacting with and could influence for well or ill. This is an absolutely brilliant diagram. It is out of the Cabinet Office report that the government put in the web about a month ago and took off 5 hours later. Fortunately, I managed to get a copy of it, but it emphasises the social systems aspects, the stakeholder engagement issues that Maxine was talking about, critically important to align businesses, markets and institutions within net zero, so we become a net zero nation, not just a portfolio of net zero projects added on to business as usual. Business as usual will not deliver. We need to create an enabling environment so that the low carbon choice is the default. At the moment, I turned down an offer of a free heat pump for our house because it involved ripping the house apart in order to make it heat pump compatible. Now, I don't know what the solution is, but it sure as heck isn't putting heat pumps into 1930s bungalows in Scotland where we can get sustained periods of negative temperatures. And all citizens, all businesses, all organisations have to play their part. And how do we do it? My summary suggestion would be, how about everybody use the donut for everything? Because that lets you map where you're helping, where you're making things worse, where you're costing stuff, where you're benefiting. And as others have said, net zero is only a step along the road. The goal is 1.5 degrees, which means that we have some chance of not having billions of people forced into migration across a world that doesn't like migrants, and where we will not be bequeathing to our children a desert planet. I mean, I thought that Dune was supposed to be a fantasy far into the future, not an accurate prediction of what the world could be like in 50 years' time. And to that end, it's not just net zero by 2050, it's big emission reductions by 2030. And Systems engineering is not about faith, it is not about hope, it is not a religion, it is about evidence. In God we trust, others must bring data. And if you say you're going to get to net zero, how are you going to measure it? How are you going to confirm? As Guy said, how are you going to look back when you find you're not on target? Summary, the way I think about a systems approach: purpose, context, measures of effectiveness. Measures of effectiveness not just about the primary goal of your own system, but also measures of ineffectiveness in terms of damage it could be doing elsewhere. Context is energy is part of the donut of human well-being and planetary boundaries, and Britain is just one country island, nation island, hole-on, sitting in the northwest corner of Europe. Europe's another, if you like, a hole-on, and the world is another one. The world is a pretty conclusively closed system. The only inputs we've got are solar energy and a little bit of wiggling of the water thanks to the moon going round. Other than that, we're on our own. And if economics is anything now, I think it is the religion of perpetual exponential growth on a finite planet. And physics tells us what to do about that. And of course, net zero needs to move on to carbon drawdown by the end of the century. So my favourite quote of all time is from Eberhard Rechten, this sort of guru of systems architecting, who I had the privilege to meet once, not long before he died at an INCOSE meeting. He died after the meeting, not at it. The original statement of the problem is seldom the best one and may not even be correct. My own quick one is breadth before depth. And the key thing about systems architecture is the leverage is at the interfaces. Don't guddle away inside the system. Define what needs to be done at the interfaces, let the experts sort out the detail. But be very careful that you don't miss things out. And is that it? No, it's not. Yeah, so my quick rant about bioenergy, carbon capture and storage. Those of you who are familiar with it know it is about taking trees, burning them, and I'm focusing here on electricity generation using BECCS. Take bits of trees, burn them to generate electricity. If that is the right answer, what is the question? It must have been, what is the most inefficient and technologically uncertain way to sequester carbon while causing maximum disruption to communities, maximum ecosystem damage, and maximum biodiversity loss over the largest possible area of the Earth's surface? And I didn't make this up, I did the analysis, I'm not going to take you through it, but if you want to power Scotland, a nation of 5 million people, relatively low population density, you can provide all the energy that Scotland needs, all the electrical energy that Scotland needs, with 1% of our country using solar power, 4% using wind. If you want to do what DRACs say they do, which is use waste wood from forestry, you need to cover 1.6 times the area of Scotland with forestry in order to power Scotland with wood. And all systems architectures, I would contend, okay, most, turn out to be driven by one or a very few controlling dimensions, and never lose sight of what it is for energy systems. They are energy density and conversion efficiency. And silicon cell or photovoltaic cells are the best way to convert energy from the sun to electricity. Anything else is probably wasteful. And yeah, so systems engineering is a learning journey. It's been an incredible learning journey for me, and I'm delighted to see that other people are picking up the learning and moving on from where I left off. As I said, my job is done. Systems engineering is the only proven way to tackle unprecedented transdisciplinary problems while successfully managing risk, interactions, and unintended consequences. And because we keep reminding you of the risks, interactions, and unintended consequences, we are an annoying bunch, but you do need us. Thank you very much.
Great, Hilary, thanks a lot. Our final panelist is Keith Bell. Keith is a Professor of Electrical and Electronic Engineering at the University of Strathclyde. He holds several positions, including Scottish Power Chair in Smart Grids, Co-Director of the UK Energy Research Centre, Scientific Director of the Electrical Infrastructure Research Hub, and in April 2019, he became a member of the Climate Change Committee. He is a chartered engineer and has advised many government departments and Ofgem on power system issues. Thank you, Keith.
Okay, thanks very much, Peter. And hopefully the right screen is being shared, is it? No, it's, hold on a minute. Oh, yes, we are. Okay, so hopefully, Peter, you can see a title slide, a systems approach.
Yes.
Yeah, you see, oh, cool, I'm right in the right place. So, yeah, I mean, my fellow panelists have said a lot of good stuff already, and I'm wondering what else to say before we open up to Q&A. I remember actually, even as a power systems engineer, I mean, you know, the clue's in the title, power systems and engineer, words which we've used already. Back in the days when I was working in National Grid, oh crumbs, this would be sort of 16, 17 years ago, I found it difficult to get the director of the business unit I was part of to think of the system and not just a population of assets. So, you know, it's still a bit of a challenge to get us to think about the kind of interconnectedness of things. And yeah, Hilary, I think, made an excellent point there about, among many excellent points, about the trajectory of emission reduction in the next 10 years, something that you know, the negotiators assembled just down the road from where I'm speaking to you from in Glasgow. Hope they get to grips with that imperative in the last few hours, or if it goes on a bit longer, day or two of the COP, in respect of the NDCs adding up to something meaningful. So it's another kind of reflection here on, you know, the imperative, the need to do something, and the climate change committee's perspective on it, as set out in the advice on the 6th carbon budget, which are commonly referred to as the rainbow of abatement. So the main point of showing this slide is that, you know, there's a lot of action needed. For example, in the decarbonisation of electricity and the electrification of a lot of energy demand. Now, another way of looking at the energy system is via a Sankey diagram. So here's one taken, I mean, using data from BEIS, from the Department of Business, Energy and Industrial Strategy, as recent as we could get it at the end of 2020. And this is from a report just published a couple of weeks ago, actually. And we can get a sense of the scale there of, well, all of the fossil fuels, things that we're using now that if we're going to continue using them, we need to capture the CO2. Yes, that's a challenging process. The alternative is we need to eliminate use of those. And it's not just about CO2 either, it's about all greenhouse gas emissions. And that was one thing that was notable from the COP last week, is some sort of commitment on methane emissions. But this energy system, with its various sources, sinks and vectors, carriers of energy, sits within a wider system of all sorts of social and environmental factors. And I'm not going to attempt to go through all of these, but it's just to sort of show the complexity of what we're dealing with and the importance of it in all dimensions, really. And we've mentioned already, I think all of us are speaking so far in this session have mentioned these societal factors. There's a little kind of pie chart that was published by the CCC in the advice on net zero a couple of years ago, I think, first of all, and which, you know, highlights the sort of interaction between sort of social and technical factors. So, yeah, use of technology depends on choices made by energy users, but technology can make behavior change easier. And there's a question then of how to influence those policy choices. And yeah, some of the stuff that you know, Hilary and Maxine have highlighted kind of illustrate that. Now, one of the particular challenges, I think, in this energy system transition is that, okay, we've been relatively successful, I suppose, in the UK to date in reducing emissions. But most of that, all of it perhaps, has been thanks to supply side technology measures. For example, the source of electricity. Further reduction is going to depend a lot on changes on the demand side. And that depends, whether we like it or not, on societal or behavioral change. You know, if we change our heating systems in our homes or how we get around, that is inevitably going to confront us, and we're going to have to face up with doing things in a different way. Perhaps not a radically different way, but different anyway, and there's going to be some disruption while we make some of the changes. Now, another thing we kind of tend to overlook and shouldn't is the need to also be much better adapted than we are to the climate change that is already happening in every part of the world. Now, here's a book that I read a couple of years ago, and I recommend to any policymaker or former policymaker for that matter. I mean, actually, they could write an entire, you know, new edition of this, or volume 2 devoted. I mean, if sadly one of the authors passed away a couple of years ago, but if they were still alive, they'd be able to spend a lot of time writing about the various things that have happened during the pandemic. But I want to highlight here the second quote most of the policymakers responsible for the blunders discussed in the book assumed they had done the hard bit when they had decided what government policy should be. Clearly, they were wrong. And this is something that maybe a guy who talked about a bit earlier as well. The detail of the how matters, not just the what. So although I think it's right that we, as Hilary said, we do need to understand the breadth, I think we also need to understand the depth. And that requires specialist expertise, but also decision-making that is cognizant of the bigger picture. So yeah, we've been bandying around this term, a whole system approach, for quite a long time, as people like Mark and Sarah have noted in the chat, for example. So yeah, it's fair enough, but what does it actually mean? What does it mean in practice? Does it mean that everything, one has to take everything into account at all times? Is it really possible for any one person or institution to hold all of that stuff in their head at the same time? Or what are the keys to making a whole system approach practical? And it seems to me that there are these kind of 4 elements to it. The first one is recognizing the links between technical, economic, and social influences, and for us in the energy system, between the different energy vectors. But also then being clear about boundaries and responsibilities in terms of the kind of physical system, but also the sort of social system, and what factors or influences cross those boundaries. And noting that not everything is measured in the same way or is directly comparable. How do you put a value, for example, on a particular habitat, a monetary value on a particular habitat, or well-being, a life well lived, compared with the cost of different types of engineering infrastructure? I think it also requires engaging people who know the detail while retaining the bigger picture. And I think that requires iteration between different scales in terms of time and space, and between different spheres of authority. And that maybe leads to this last point, which perhaps is the most difficult one: being prepared to cede authority to those responsible for the bigger picture, even if you don't fully trust their competence. So therein lies maybe a very particular challenge. And yeah, we're in a situation now in respect of climate policy of moving, I think, from ambition to action. And then that entails the monitoring of policy, going through these different steps. And as others have already said in this opening to this session, there's a need for sort of understanding of how these things are progressing, calibrating and validating what's going on, dealing with the uncertainty that's involved, and being prepared to implement feedback loops where even ambitions are changed, certainly where policies need to be possibly modified and implemented in a different way in response to the evidence about how things are turning out in reality. Okay, I think that was all I was going to say. Thanks very much.
Thanks a lot, Keith. That was excellent. Cheers. I've seen there's the Q&A started already, so we'll come back to the Q&A in a little bit of time. But if anyone in the audience has questions, you can just start to build up that Q&A content at the moment. But first, I'd like to just go out to the panelists. Let me just make sure this is set on the right view there. Gallery. Okay. So yeah, one of the themes I was picking up on in the presentations there, I mean, particularly Guy and Maxine had both talked a little bit about modelling or system mapping and feedback loops and things like that. I'm interested in the notion that, that we are all part of our own system in terms of trying to help sort of build a future energy system. And I'm wondering, therefore, what can we do to help break down silos that might help us really collaborate on things like system mapping, causal loop diagrams, whatever it may be, and actually really develop that knowledge sharing aspect. Guy, if I could maybe come to you first on that, please.
Sorry, Peter, you cut out. Sorry, it's probably Wi-Fi my end. Do you want to just repeat the question very briefly, and I'll come back?
Sure. Yeah, so I'm interested in exploring around modelling, system mapping, feedback loop, and things like that, and what we can do to help break down silos that would allow us to really collaborate on these things and not develop different perspectives of the same system, but all in silos. How can we get more knowledge sharing around those things?
So I think that's a really important question. I think the challenge that comes for that, which is always a challenge when you're talking about systems stuff, which is what my colleague Eric Brown calls the Monday morning problem, right? Well, okay, this is all great. What do I actually have to do on Monday? And you know, the critique of systems thinking, or the criticism that comes in is going, oh, you're going to spend months and months drawing these bloody beautiful maps, etc. And but we need to get on with it, of course. Obviously, that's a pastiche of what the real challenge is. So I think, you know, I think what's really important in this kind of breaking down silos questions is, you know, working on particular problems and showing the value. That's part of the reason I wanted to highlight the local side of it, because I thought that was that for me, I found a really powerful way of thinking about this issue, i.e., okay, right, if we're going to decarbonize, you know, Glasgow or Bristol or, you know, Norfolk or whatever it is, you know, we to have a proper pathway for that and to think about what the important things are, you have to think about across the different silos, you know, and I don't mean that just across, you know, gas and electricity and transport. I mean that across all the dividing lines that Maxine and others have talked about. You've got to have the full element in there. So I think the challenge now, which is, you know, we've in many ways won the kind of intellectual argument about the systems approach. Now it's about proving it in an energy context and an energy decarbonisation context in a very practical way, which is going to show the value of how you break down those silos. And without that, and you see that from the net zero strategy, which in many ways is a great document, certainly better than the one I was involved in, the clean growth strategy. And they've got a whole section on whole systems, and they've got a, you know, a systems map and things like that, but it's not joined up with the rest of the document. You know, almost it's like, oh God, we've got to think about this. There's nothing. So I think it's really challenging from there. Right, people get it. They've got to think about various elements of the problem, which to lots of policymakers is a natural thing. This provides a systematic way of doing it. But what do I do on Monday morning? I think that's the point I would say on that, and really focusing on the practical application of systems engineering, and then the value will become really apparent.
Great. Maxine, if I could just turn to you as well. So what techniques can we use to bring in stakeholders such as perhaps a consumer, so that on the journey to net zero, we actually all pull in the same direction, and it may be part of that sort of, you know, exercises such as system mapping. How can we bring the right stakeholders in on these activities?
So I think, you know, I mean, the kinds of models that are really most valuable, I think, in bringing citizens' views in are the kind of citizens' juries. And so we've had the Climate Assembly, which we had in England, but I think Scotland also had its own climate assembly. And those are ones where people are taking time to understand all the different dimensions of the problem. I'm not sure that people would be sitting there drawing systems maps, but I think for you know, as probably we came out from the beginning of this conversation, this is at least as much about that process of making sure you're thinking about the different elements and the interactions between them and the different parts of the system, as it is trying to draw a systems map. And I think the same thing goes for the stakeholder engagement. You know, I liked Keith's line as well about how do you manage with the kind of complexity of it and the cope with, you know, can you think of everything at the same time? And you know, one of my lines with stakeholder engagement is that, you know, there's an opportunity at which you get all the stakeholders from all different disciplines all together in a room, and you're talking at a high level about the system. And then, you know, there are other times when you want to get a smaller group in a room, and you're talking about kind of one little bit of the system and trying to really understand, you know. It's nothing like putting somebody from the water industry in the room with somebody from the electricity industry, and you know, and if they have a conversation for an hour, they'll find all sorts of linkages that nobody would have thought about. So, you know, it's just giving those opportunities for conversations. I think the question of the system mapping exercise that I referred to, that Guy and I did, it was purely a kind of a test run exercise to sort of see whether that was a useful tool as a way to structure those conversations. And I think we came away thinking it was the way that it was run, that exercise was quite good. But you know, I think that's one way of getting into some of these conversations, but it certainly isn't, you know, it certainly isn't the only way. But it, so in some sense, it's systems thinking in its broadest sense, not system mapping as a specific tool or technique.
Hilary, you've got your hand up. Would you like to come in on that?
Yeah, I was just going to add very briefly, and people get very interested in models. Actually, an awful lot of the benefit is the modeling, and the people who are building a model and interacting with others to refine it, getting a lot out of the exercise, generally far more than people who just look at it when it's finished. And so modeling is a social activity, so the more people you can involve, and I think as engineers, we have a restricted view of what a model is and what it's for. And for this wider system engagement, it is the modeling, the engagement, helping people understand by looking at the way the model's evolving, what the impacts and implications are. How you disseminate that to a much wider audience than are involved, I don't know. But that is the challenge.
Yeah, Peter, I don't know if I could add to that. I mean, I think that thing about the modelling, yes, that's a lot of what I spent my career doing, what my group does now. But I think one of the most important things you can get out of a model is actually the ability to identify the next question. Yeah. So it progressively improves your knowledge and understanding. And if you're kind of doing it in a kind of a critical way, reflecting on the weaknesses of the model, hopefully you're not just going to sink into it of kind of assuming that something is right because the model tells you so. So a model should be seen as an aid to thinking and understanding, not a replacement for it. And then, otherwise, I agree very much with what Maxine was saying about, just talking to people, talking to each other, getting an opportunity to sort of understand the different perspectives and to get the benefit of different areas of specialist knowledge and see how the different things for which we're responsible interact and the interdependencies across them. Now that's a time-consuming process. So I see Mark Winskill in the chat has written about how this kind of bringing different academic disciplines together within the UK Energy Research Centre, it turned out to be a very time-consuming process. I mean, it's especially time-consuming when there's a bunch of social scientists that want you to spend a week just defining energy. I mean, maybe that's a very important thing to do, but it wasn't maybe what everybody was expecting to spend their week doing. So there are some things we maybe have to sort of use a working assumption in order to then really get into the different sorts of insights that the different disciplines can bring, and then also to define the what next. So it's great having these conversations, and really enjoyable, and I think really important. But then what are we going to do with them? How are we going to use the knowledge? And then you come back, I think, often to the sort of regulatory and commercial structures that Maxine in particular will be familiar with from Ofgem, but I think all of us have working within, and the extent to which they perhaps act as barriers to doing the things that all these people talking together have identified need to happen. What are the responsibilities and what's the scope of different institutional actors to do something about the new insights they've just gained?
So touching there on things like regulation, I mean, with such an appetite for a systems approach, is there a need that we would have some level of regulation or perhaps standardization across the industry that would ensure that we all take a concerted approach on this and something that we can sort of benefit from? Guy, is that something that would actually work at all for regulation of the kind of systems industry, the way we do things, or could that be a bad thing?
Yeah, I mean, it depends exactly what you mean. I mean, I'm always cautious of kind of mandating an approach, as it were, to any particular problem, particularly when there's kind of, whilst it has moved forward a long way, there's still a lot of skepticism about whether it's, actually practically beneficial. I think the way you get people to do it more is you prove the value of it in particular examples, and then people want to do it. And so, that I think that's the stage we need. We need kind of, a set of problems that systems approaches are applied to. People realize, policymakers, regulators realize that's a really valuable way of cracking the problem and moving forward on it faster. And, some of the examples have been talked about. tend to think that the data task force used lots of these elements as well, and is showing that you can then progress can move faster in the real world, as it were. So I'm skeptical of the mandation of any approach generally. It's about proving its value.
Maxine?
Yeah, I was really just going to build on the point about, certainly not in favour of mandating, but actually making it easier to look across sectors. So we do have at the minute, we actually have the position where we've got, even Ofgem has separate legislation covering what it does on electricity and on gas. So strictly when it's making a decision about the electricity system, it just has to think about the electricity system and what's in the interest of electricity consumers. And so I think a kind of something in the regulatory framework that urges, or that requires the regulators to consider the wider impacts. And I mean, one of the things that's been talked about is a net zero duty on all regulators that at least gives them something that they're pointing towards a common goal and a common objective, more important than a kind of particular tool and technique.
Hilary, I think you had your hand up next, and then Keith also has his hand up.
Yeah, I was going to say that 2 points, I think. One is that any method, process, or whatever that is flexible enough to allow innovation has to be also flexible enough to allow mistakes. So mandating a process that allows you to do almost anything doesn't stop you doing things that are really stupid. You have to think. The other thing, there's an interesting question about siloization of the government departments, and this is coming back to the same thing and what Maxine said a moment ago. The more I think about it, the more I like Kate Raworth's donut model. My Monday morning recommendation would be every policy decision should be very quickly mapped against the donut. All you need to do is red for makes worse, green for makes better, grey for doesn't affect either way. And then you've got a language and a framework that is very easy to use if you have enough information to populate it. I'm not asking for, is it 1, 10, 100? I've heard once you start trying to quantify things, everybody argues about whether it's 1.7 or 2.1, not about whether it should be getting bigger or smaller, or not about whether it matters or not. So we need very simple, broad brush approaches to track, are we making a difference? Do we know enough to decide whether we're making a difference? And before we only dive into detail when we need to, when there is a value of the information provided by that detail.
Keith?
Yeah, I think, well, one of the things that the Climate Change Committee has recommended to governments, plural, is the introduction of a net zero test on key policies or decisions. I mean, we've avoided defining what that net zero test would look like. We've had a few discussions sort of behind the scenes about what it might look like, what form it might take. But I mean, I think to kind of look through that kind of lens, I think is extremely important. For example, this is just me talking now, not an official CCC line by any means. What is the kind of consistency between a 20-odd billion pound road building program and a commitment to active travel? The codification of a systems approach. I mean, one thing that struck me about Guy's presentation in one of his slides was including the word market or a box for markets, rather than say labeling it as society. So one thing that I guess a certain sort of, maybe the dominant sort of political economic ideology over the last 30 years or so has asserted is that society's interests can be represented through markets, and are markets alone? Maybe you kind of complement that with some sort of regulation of markets. See Hilary kind of tearing whatever. Okay, I won't comment about how much hair is left. But I mean, look, we do have markets. There are these kind of, there always have been, I think, from as long ago as humans started writing things down. So which is where our records began. Ways of interacting through transactions, and the codification of a systems approach, you could argue, is represented through the market structures. If there is a price for something, and there are alternative prices for different ways of doing things. Let's say, alternative ways of getting your energy. In theory, if all of those prices are clearly articulated relative to what the costs really are, and you're a rational actor who's got access to all sorts of information, okay, there's lots of impossible things to believe before breakfast then. But in theory, if all those things are true, then you have a way of codifying the kind of system-wide interactions and of making rational choices. I just put that out there.
Have you got any thoughts on that, and on how the market represents society? Is that true or not? How the pricing and things impact the wider energy system?
It's a big question. I think in Keith, it was actually I felt a bit uncomfortable about your characterization of markets there. I mean, markets are just a way of making choices, really, and they are heavily socially created. The idea, people often say, when we say, you're in favor of markets or you're in favor of no regulation, like, no, not at all. I'm just in favor of creating processes where solutions to problems emerge rather than choices being made about specific technology.
Believe it or not, I was trying to sort of be sort of, I don't know, to highlight where markets can be useful. I probably didn't put it in such a way that was clear. Sorry, Guy.
Good. And I think, and of course, in the UK, talking about what systems approach, in the UK context, the pricing mechanism, the incentives, as we pointed out, and the CCC pointed out, many others have pointed out, are a total mess. They're the total opposite of what you want. So, in some sectors, aviation, agriculture, home heating, we're effectively subsidizing pollution. We keep talking about this tremendous climate crisis, but we are subsidizing the alternatives. And indeed, the budget made some of the stuff worse, which is crazy. And the effect is, for all the innovators we work with at the Catapult, it's like, well, if you don't give me a level playing field, then I'm relying on people's goodwill, and not just their goodwill, more than their goodwill, on doing the right thing, which is a pretty weak driver. I think people are concerned about climate change, but they're not going to pay 300 quid more a year for their heating bill, especially if they can't afford to. So that's why the market side is absolutely important part of aligning everything. And it's I thought the Hillary's characterization was quite powerful. Like, how do we get all this stuff lined up so you're encouraging as much of it to work together in the right direction as possible to achieve the societal outcomes we all want, or say we want.
Maxine?
Yeah, so I was just reflecting, having been at a few fringe sessions around the COP. I've sat in on a number of where people have been calling for systems change, by which I mean get rid of the capital system that we all live in, and some quite heated discussions around that, and trying to think actually at the time about how that fitted into a discussion about systems engineering. And I think those calls are coming from where one is seeing the impacts of capitalism in kind of ravaging, destroying rainforests for commercial ends and other things, and inequalities across the globe. So obviously, we are well used to a market mechanism here, and I think the debate was, well, what's the alternative? But I think some of the problem comes when you've got Hillary's donut, and you were saying, you need to wake up on a Monday morning and is it going to make things better on biodiversity and, all of the different things that we need to get right if we're going to end up in a better world. And so many of those are not valued. And, I don't know whether the answer is to try to put a price on everything. Clearly, the more things that we can actually put a price on, then the better the chances that our market mechanisms will lead us to some sensible outcomes, because I can't see an alternative to a market way of dealing with much of this. But we need to be careful that there's an awful lot, and there's a lot of discussion these days about valuing natural capital and trying to put a value onto those other elements that are not currently valued, and I think that's an important part of it. And again, that then enables you to look at a system in a way where you are looking at all sorts of different outcomes, not just the financial ones.
Keith?
Yeah, Maxine, you made one of the points I was about to make actually about the things that are valued by the markets, and there's lots of things that aren't. So, for example, you know, I think people like Cameron Hepburn and whatever made this sort of point about, you know, the natural resources that become depleted. You know, when you're extracting fossil fuels and then putting it into the atmosphere, that's not, you know, both the depletion of the resources and then the kind of negative impact on other parts of the natural environment, not priced in the right way. But Guy's absolutely right of, you know, the importance of price signals as a way of making sense of choices. And I think Guy's also absolutely right about whether there are biases within the sort of, well, influenced by the taxation system and subsidies and all that sort of thing, and whether you know, those mechanisms that policymakers have available to them are being used, the levers being pulled in the right way, at least towards towards emissions reduction, but also having awareness of the sort of impacts, you know, on, for example, people in fuel poverty. And then I think, Maxine, as well, what you say about the valuing of natural capital. You know, I'm conscious of, for example, you know, some of the systems impacts, you know, impacts out with just to say the energy infrastructure on the natural environment and the local environment. And one of the big challenges I think we're going to have to face up to is about planning and getting planning consents for infrastructure developments. You know, when it takes 10 or more years to get approval for and the construction of an overhead line, for example, we're going to be massively behind the curve because whatever we might believe or want to believe about local and community energy, you know, economies of scale matter a lot when looking at things like offshore wind and whatever. And you've got to have the means of getting that energy from the source of production to where it's being used. So how can we make sense of these tensions between local priorities and the kind of bigger picture again? So are some kind of formal ways of making sense of natural capital, do they help navigate these tensions? I'm not quite sure. I'd be interested in others' views on that.
Hilary, you've had your hand up.
Yeah, I was going to add that money is just a measurement. There is no intrinsic value to money. It is just green bits of paper that we move around under the impression they make us happy, to quote a great scientific author. I've forgotten his name for a moment, Hitchhiker's Guide to the Galaxy. But yeah, money is information, and the information money conveys is what we should do when we're faced with the choice, to which money is part of the solution. The problem with money is it actually measures stuff, and once you start measuring a system, you change the behavior of the system, and we see that. So we can use money signals to skew the market towards the policies we want. But I don't think you can put a value. How much is that tree and that meadow worth compared with that opossum and that bit of Australian bush? I mean, these are just crazy choices. So we've got to be a lot more realistic than current economic fundamentalism is about what money can actually tell us what we can use money for and what really matters. There's a lot of work going on in Scotland at just now. I'm not up to speed with it, but Catherine Trebek and others about the well-being economy and trying to understand how to move things away from this obsession with the GDP to something that actually matters to real people living real lives. And the other thing I've only just realised is that I was reading something totally unrelated. This is down to this little flag here in the background. Nationalism is a much misused word, but fundamentally it's about place. This place is important to me. And some person on the other side of the world suddenly deciding they're going to plough up several million hectares of Africa and plant trees there, that is the worst form of colonialism. So it's not up to somebody else to decide how much my environment is worth. So I don't see how you can reconcile these. This brings us back to the concept as a whole on. Each country should in principle be trying to sort things out within its own boundaries. A bit difficult for Singapore, which doesn't have, I mean, there are still jungles in Singapore. You can get lost for days in the Singaporean jungle. But if Britain thinks it can solve its net zero problem by shoving our emissions somewhere else, we're not actually helping the world, because we're probably better at dealing with our emissions in a lot of the places we're shoving them away to. Another rant, yeah, the key point is once you start putting money value in things, you actually change the system that you're trying to protect. And that's a big risk.
Guy, would you like to come in on that?
Yeah, I don't think cutting down I don't think, you know, planting trees is the worst form of colonialism. I suspect people in the Congo historically would see that some of the Belgian interventions, and no doubt some of the British interventions, are much worse. But I do take the point that Hillary is making. I think one challenge, I don't think GDP is the enemy here, and I don't think, by the way, that policymakers think is the only measure of success. But, you know, having spent a lot of time in China, China has obviously got huge environmental problems, but it is a much better country and much better for the people who live there, because it's grown over the last 30 years. They have much better lives than they did before, rather than backbreaking poverty with, you know, millions of people dying in the Great Leap Forward. So I take the point, but I also think that there are you know, the challenge is environmental destruction. That's the thing we should be focusing on. I absolutely, not myopically, we have to think about all the other things, and good systems approach would do that. But I think achieving it by degrowth is politically unlikely, and I'm not particularly sure desirable either. Is my rant.
I totally agree with that, and it comes back to my point about money as information. One of the biomimicry principles is run on information, not material. And if we can make people happy by streaming Netflix at them, or by having them go out for walks in the countryside, then that can be just as valid a form of economic growth as making more stuff that we throw away. So yeah, totally with you. I'm appalled by degrowth for the wrong psychological signal it sends out. I've actually tweeted to Jason Hickler once or twice, you ought to have called it enough, not degrowth. And he replies, there's a very good academic foundation for degrowth, read the papers. No, sorry, people don't get past the word. If you get the front end wording wrong, then everything else is lost.
Okay, during some of the discussions we've touched upon, you know, a just transition and some important things such as eradicating fuel poverty. Home heating was one thing that I think Maxine had mentioned during her presentation at the start. So I'm wondering how decision makers and policymakers, or even anyone who can influence the system, how do we actually navigate a credible and socially just pathway if the subsidies and the incentives that we make available actually don't apply to the entire population? So for example, if we're going to incentivize perhaps say EVs, not everyone can buy an electric vehicle, and therefore if taxpayer money is going to be used to provide these incentives, there's a real complex sort of cycle going on there. So Maxine, I wonder how can we balance all of these constraints and still hold our aspirations of a just transition and eliminating fuel poverty?
No, I mean, it is a really important question. I mean, I think one of the things is just being clear why you've got a subsidy in the first place. You know, so sometimes you are just trying to kind of get a market started, and you know, you recognise that there's a benefit in, you know, as I say, if you've got a few people with solar panels on their roofs and other people see them, then they start to, you know, that kind of normalises it, and you see it happening. But we did find, you know, so the feed-in tariff subsidy for solar panels was structured in a way that meant, because you had to find the upfront costs, people in low-income households very rarely took them up. So, you know, there's a kind of being clear when you're thinking about any policy, who's paying for it and who's going to benefit from it, and just doing that analysis properly. I think you're then going to have you know, there is subsidy and support that would go to those that really can't afford to upgrade their homes. You know, we already have some of that in the policy framework we have around insulation measures. You know, there is actual you know, grants available to those on lower incomes rather than you know, making those kind of support available to everybody. But some of it is, and Guy talked about thinking locally. You know, I think particularly for heat decarbonisation, it's really important that you get that thinking done at a local level, where, you know, the local authorities will know the kind of who's in fuel poverty in their area, or where the areas of deprivation are, and the kind of housing stock, and can perhaps come up with solutions that meet those local needs better than anybody trying to come up with a one-size-fits-all from central government. And that's both about the the solutions. You know, is there a source of waste heat that's available in the local area that could be used for a district heating system that could be targeted on those that are in fuel poverty, and how can we, you know, just think about our local neighbourhoods in a better way. But it, you know, I mean, it clearly is a real problem, but it's one that's got to be tackled if we're going to take people with us, because you know, we cannot have a system where everybody, you know, there are those who are least able to afford to are having to pay more to support a transition that are not benefiting from.
Guy, I think you had your hand up.
Sorry, yeah, I did. Yeah, thanks, Peter. So I got in trouble on a panel recently when I said we should use the phrase "rinse the rich" to drive innovation policy, and I agree with all that Maxine said about the importance of protecting the fuel poor and the new types of vulnerability which are going to come from a smarter energy system, which we've really got to think about. But the point I was trying to make with my perhaps overly aggressive phrase was, you know, you look at lots of the innovation transitions in history, you know, you take advantage of the fact that, you know, early adopters are willing to pay, and, you know, often the kind of wealthiest to show off, right? You know, mobile phones are classic, the kind of yuppies with their bricks, you know, and now, you know, that's led to an absolute, you know, part of that has led to a transformation where, you know, everyone can afford a mobile phone, and they've come up with different solutions for different segments of the market, and it's had huge benefits in that way. I hope we're going to get there with electric vehicles. You know, there's a reason that Elon Musk started with, you know, 70 grand car. He's now getting to a 40 grand car, when, you know, and we're starting to see from the other end, you know, the Chinese manufacturers coming up with kind of 5-10 grand cars, etc. Of course, most people don't ever buy new cars. It's worth saying. Most people buy cars secondhand. So the key question on electric vehicles is, can they be sustained over 20, 30 years, running costs, etc. But actually, you know, taking advantage of the early adopters to drive improvements which everyone can benefit from is a really important part of the innovation cycle. And again, we should be grateful for people who waste money on stuff that doesn't work quickly because they're trying to show off to their friends.
Keith.
Well, one thing, Guy, about rinsing the rich, they should feel very clean afterwards. So, you know, I mean, maybe it's not such a bad thing. I mean, a lot of what we do now concerns, and what we want to do in the energy transition concerns more expensive capital stock than the sort of equipment we've used before. And, you know, this points to something that Maxine already said. I think, you know, the structure of incentives or subsidies is therefore important. You know, whether it's the upfront cost, you know, whether it supports kit or its utilization or some combination thereof. I think it also depends on enablers, you know, in particular shared infrastructure. You know, we think about, you know, fiber technology to enable access to broadband, but it's a similar sort of thing for energy network capacity and electric charge points. And I think in that respect, we shouldn't be overly afraid of the risk of stranding of assets. Yes, there are uncertainties about exactly how this energy transition is going to play out. I think Guy showed, you know, a good slide from the Energy Systems Catapult that illustrated that. There's another nice illustration in the Energy Technologies Net Zero Guide that we produced at Strathclyde recently for the IET, where we compared these different, you know, pathways. But anyway, you know, there are different pathways. But there's one thing that should not be uncertain, which is our need to get to net zero. And as somebody was putting in the chat, the need to get there quickly because of the cumulative effects of emissions. So there should be no doubt about that direction of travel. And I think you should also not be overly afraid, not just of the risk of stranding of assets, you should not be overly afraid of socializing the costs, or many of the costs, of the sort of shared enablers.
That's great. I just want to jump quickly into the Q&A, if I may. So Ron Loveland has put a question in: how can we overcome the siloization of government departments in the net zero space? And Ron points out, until we have an integrated government, if we don't have that, we're going to be in trouble. Would anyone like to take that? Guy, look at your hand up.
Good to see Guy putting his hand up straight away on that one.
Yeah, so I've thought a lot about this, as Ron knows. So, you know, when I started off, I worked for the Department of Energy and Climate Change. That was one attempt to kind of put it in one department, which had lots of benefits, certainly had a kind of cabinet level focus on it, but it was a relatively weak department versus the rest of Whitehall. Then I worked for a bigger department, the Department for Business, Energy and Industrial Strategy, and the big fear there was that climate change would get kind of marginalised in that department. Totally not happened, completely taken over the department. In fact, it's the old bit of biz that I would say had been marginalised. Get myself in trouble for saying that, for anyone there, from there, which is great, and it's, you know, it's matured that. But ultimately, when you're in Whitehall, the only thing that matters is political will from the centre. And when I say the centre, from, you know, number 10 Treasury at the heart of that. And one thing that has happened, which I would have absolutely been desperate for over the last few years, is we have a cabinet committee chaired by the Prime Minister to do with net zero, and you have an implementation committee to do that. You then have a kind of there's a horrible acronym, NSIG, nationally significant or something, which, you know, organises and produces papers for that. That is a much better step, of course, because as government we have absolutely no visibility of what they talk about, what they discuss, which I don't think is helpful, but I completely understand why it happens. So that's a good step forward, and that, you know, that is different departments putting their feet to the fire. But there is no substitute. There's no system or structure or way of organising government which substitutes for politicians actually wanting to do something. And if the Chancellor's not that bothered about net zero, or the, you know, Secretary of State in front of Transport is not that bothered about net zero, by the way, it's not specific about the incumbents at the moment, but if they're not that bothered about it, and they're not going to take meetings on it, and not going to drive their officials to do it, you know, civil servants follow where the incentives are. Of course they do. So they will, you know, move on to other stuff. So it's all about convincing politicians this is important, it's electorally important, it's the right thing to do, all of those reasons, and that's the most valuable thing that will drive change. Those structures kind of help, but those structures are Potemkin unless there's something real in there.
So Jim, would you like to come in on this one?
Thanks, Peter. I'd noticed the comment in the sidebar, but I didn't want to intrude. Just on that one in particular, and I think it's like an important question. I can simply say from, I mean, Guy has been up to his ears and actually living that experience, and I'll tell you about me getting my feet wet in the policy domain over the past couple of years in particular. I think the appetite for that systems approach is there. And I feel it's gone beyond simply an interesting discussion point. And if I give you the Royal Academy of Engineering perspective, we have a policy fellowship programme which has now been heavily subscribed across government departments. It's a fantastic cohort of sort of early career civil servants, predominantly with a science and engineering background, and that's fine. But as the comment in the side box also noticed that Patrick and I have been promoting this regularly, and Patrick has now got just about all the chief scientists across every department signing up to promote and give the opportunity for their staff to engage. And I won't take time up, Peter, at this point, other than to say that it allows us to allocate a senior fellow of the Royal Academy of Engineering, or more than one, in a mentoring mode and support mode to what tends to be fairly thorny problems that are brought out of each department. And invariably we start to get that crosstalk. So it's building slowly, piece by piece. The policy profession, which again, Guy, you and others on the call will know about, these discussion points have also been raised very recently, I know that, by Patrick's team. So it's softly, but if I read the runes, as well as the senior civil servants and the chief scientists talking about it, the politicians that are leading these departments are now, they're interested enough to find out more. So it's not just coming and going, but we'll have to be relentless because it can't be an initiative. It has to be a way of doing our business, and that's going to take time.
Yeah, thanks for coming in on that, Sir Jim. Absolutely no need for the apology. I think everyone wants to hear your important perspectives on these things. Keith, you have your hand up there.
Yeah, thanks. I think that fellowship initiative, I think, is great, and I think I'll echo Sir Jim's comments there and really encouraging the take up of it. And that kind of point, that the question that Ron raised, I think I would come back to the sort of 4 of the points on one slide that I presented earlier. I think the keys to making a whole system approach practical, and this maybe works across government as well as across sort of an engineering sector, for example, is recognizing the links between different silos or different aspects of policy, being clear about boundaries and responsibilities and what factors or influences cross them, about engaging people who know the detail while retaining the bigger picture. And then this is, as I said before, and this is maybe the difficult one, where Guy talks about the importance of getting a lead from number 10 and the Treasury, who always seem to be the kind of the key players and not necessarily in agreement with each other. Being prepared to cede authority to those responsible for the bigger picture. Maybe it gets a bit difficult when you're not quite sure whether the relevant authority is number 10 or the Treasury. But anyway, yeah.
Thanks, Keith. Sir Jim, you've your hand up again, or was that an old hand?
Sorry, legacy, Mitt, I'll take it down.
No worries, no worries. Hilary, your hand is up.
Yeah, I was just going to add to that, the organisational instinct that I've observed in 40 years in industry and government and in voluntary sector is you take something like the donut and you immediately split it out into one department or group or organisation is responsible for each element in it. And immediately you're putting in silos. And there's been a bit of mention of the idea of the whole on the chat. It's not a concept I use very much, but it's this idea of an organic whole system. The other way of looking at it is that every single entity, from the world to a continent to a country to a city region to a part of a city to an individual household, can all be viewed as a fractal, all with basically the same reference architecture, if you like. My house, the heating problem of my house, if I added solar panels and a water heater, would be exactly the same as that of a country. It has all the same logical elements, it's just they're rather smaller and easier for me to understand. So this idea that we have to split things up according to discipline-based or function-based silos immediately introduces the silo problem. And if you can do that, you've got to define the interfaces very well. And in an uncertain and rapidly changing environment, that's actually impossible. So if you try to make things sort of grow organically, instead, everybody has their donut. Most bits of it will not be very important for what they're doing. But if everybody has the same reference frame and money does some of it, but as we've discussed, it doesn't do it all, then at least you've got a common basis for having a conversation at a transdiscipline, trans-silo level. And I think that is more important than any of us realises, because we're so conditioned to working in this silo way, we don't even see when it's causing us problems.
Thanks. I'm conscious that we're actually a little bit over time, but it's all good stuff, so I don't really want to kind of rush things to a close. But there was one final question that I wanted to get round to asking, and I wanted to kind of bring things back round to COP26 and what we've just seen. How do the agreements and the outcomes so far of COP26 affect the future energy system in the UK and the way in which we shape it? So I'd quite like to hear from each of the panelists on that, but I don't know who wants to maybe take that one first. Guy, do you want to grab that one first?
Yeah, I mean, let's see if there's an agreement. Because by the way, because I think if there's no agreement or they can't get the text sorted out, then I think all the momentum in the UK context that we've seen over the last 3 or 4 years, which have been an extraordinary change. If you think of, think back to the clean growth strategy that we did, which was nowhere near adequate, and the net zero strategy is nowhere near adequate either, but it's a massive step forward, and that's reflected in the CCC kind of response to it. So will it make much difference? So if it goes badly, it will, could be damaging headwinds. But the thing that I really took away from my brief time in Glasgow was just how much more seriously this was being taken by much more senior people in companies. So I think about what was happening in Paris 6 years ago when I was there. You know, you get your sustainability, head of sustainability would rock up to these conferences. And I know it's in the UK, but you get chief execs turning up. They want to see it. They see it as important. It's an essential retention tool, all of that stuff. The question is actually, you know, where our business can be further ahead than government and can. But again, that dance between, you know, ambition of companies, ambition of politicians, etc., is really important. But, you know, ultimately, you know, I never think you're going to solve the climate change problem in a international negotiations. It's going to be solved by innovation and making things really easy for people to do the low carbon option, and the negotiations provide a useful framework for that, but they're not enough by themselves.
Maxine, have you any thoughts on whether we've unlocked any new potentials or enablers?
So I mean, I totally agree with Guy about momentum, you know, and getting an agreement being important for maintaining that. I think the really valuable thing that from the UK energy system that was coming out, you know, kind of before the COP, but was driven by it, was more of a focus on near-term goals. So if I wind back a couple of years, one had a sense always that we were talking about 2050, and that always gave you the sense you'd got a load of time. And I think the fact that we're now talking 2030 targets, 2035, you know, means that actually it's a lot clearer when, as Keith says, it takes 10 years to build a transmission line. We've just got to get on with it. This is not something that we've got a lot of time to worry about whether we're doing it absolutely 100% optimized. Just, you know, we know the direction, just get on with it. And then a little niche one that I think is great, and I'm banging on about, is methane reduction, which is really obscure and we've not talked about, but actually, because it's short-lived, has the potential, if you can get it down, it's actually reducing the amount of greenhouse gases. And I always had a thing about Ofgem not having taken methane reduction seriously in setting the last round of price controls. In fact, they went backwards. So I'm using that to beat them up a bit and to see if we can get some, you know, so that's one where we need out of COP, we now need a new focus here, because it's not something that's been on the agenda. It wasn't in the energy strategy, you know, so that's something that's good that's come out of COP that will actually need us to change. The rest of it, I think we've done the thinking because we knew the way that it was going ahead of COP. But fingers crossed for a good outcome all round to maintain momentum.
There's probably some good lead-ins there for both Keith and Hilary. Have we got the technology and the manufacturing readiness and maturity to deliver some of these shorter term goals that are emerging? Keith, Hilary?
Yeah, well, I mean, we have got to get on with things, and you know, the commitment, we're following the recommendation of the CCC, incidentally, to have zero carbon electricity by 2035. It's a really hard one to meet. It's essential as part of the overall pathway. But you know, where are we going to get our electricity from during a wind drought? You know, a week or two of very low wind speeds, if it happens when there's high demand, when we've electrified a lot of heat, for example. We might not have electrified all of it by then. So that requires a lot of new generation capacity or storage of some form in a relatively short period of time. Of some form, there's still questions to be worked out. There are a lot of details around operation of an electricity system when you've got very little conventional synchronous plant on it. You know, the dynamics of it are very different. That's not thought about seriously enough, I don't think. I mean, people are thinking about it, but I'm not sure with the necessary kind of volume or kind of weight of effort, let's say, just yet. And I think that, plus, I mean, you know, decarbonisation of heating systems and insulation of homes, there's a huge amount of efforts needed there. And the people to do it, have they got, I mean, you know, Duncan's mentioned skills in the chat, quite right. We haven't talked about that yet. But that's, you know, it's absolutely crucial part of the jigsaw. It's one of the reasons why I don't think we can go any faster than the carbon budgets suggest, as we have to get the, you know, the skills in place, you know, the construction installation capacity, and yeah, we can bring jobs if we have the manufacturing capacity as well in place. All those things take time to build up. I mean, apparently we're told that the money is there from institutional investors. Again, this is, you know, Guy's point about chief executives turning up. You know, we're told that big pension funds and all sorts are interested in investing. So in theory, the finance as a whole isn't the problem. It's where that is exactly where that finance turns up, under what conditions, and who has access to it. And then, as I say, the kind of the capacity to deliver throughout throughout the supply chain.
Yeah, I think I'd add to that, in anything you want to have working at global or even country scale in 10 years' time, the technology is there now, by definition, because you can't develop and deploy at scale totally new technology in 10 years. And I think we do have the technologies we need. We do know how to do electric cars. The point about keeping it's been driving me around the bend for the last 10 years since I started thinking about this, the fact that we're deploying wind farms without resilient storage. But when I actually did the calculation, the worst case wind drought problem was, let's say, a week. I use Scotland as an example because I can get my head around the numbers. There's probably about 2 million cars in Scotland. When all of these are electric vehicles, there will be enough battery capacity in those cars to provide Scotland's current electricity needs for a week. So part of, a guy shaking his head, I mean, I know people are going to want to drive the cars, but we need to start thinking like that. You know, how does the whole system balance out? And by removing base load and removing dispatchable power, we're totally changing the design paradigm of the electricity system. We don't know how to do it. You've got, and the other point I wanted to make coming out of COP26 is if anybody any longer has any doubt that the large part of the population has the appetite to accept the changes that we need, if they're done fairly and explained properly, I hope that doubt has been expelled. You know, seeing the people in the streets, hearing the young people is absolutely fantastic. We have got a degree of engagement. And final point, if any CEOs are listening, we've just switched all our modest investments into sustainable funds. And if everybody who can afford to do that, if everybody who has savings does that, that is an enormous signal to CEOs. And the governments will be left behind running to try and catch up.
Yeah, it's great. Thanks. Some great points at the end there, Hilary, and from everyone in general. So just looking at the time, I'm a terrible chair. I've allowed things to go over by 15 minutes, but then again, I'm a systems engineer and I wanted to explore the whole discussion fully. So there we have it. So, I mean, unless anyone's got anything pressing that they desperately want to say, I think I'll draw things to a close there. I'd just like to thank our panelists for their knowledge and insight today. Also to our partner organisations for enabling this event, and to our audience as well for engaging. The chat's been going really busy. I haven't been able to keep on top of that at all, but I hope that everybody really got something useful out of this, and I hope you all have a wonderful Friday. And that's all from me. Thank you very much.